So we've now covered the basic L'Hopital's rule forms of 0 over 0 or infinity over infinity. The slight complication is that there are what you might call some hidden L'Hopital's rule forms, things that don't necessarily look like 0 over 0 or infinity over infinity, but can easily be converted to it, to one of those. So let's see, those forms are infinity minus infinity, 0 times infinity, 0 to the 0, infinity to the 0, and 1 to the infinity. So let's start with infinity minus infinity. The first question is, why would this be an indeterminate form at all? I mean, after all, if I take infinity and subtract infinity, don't I get 0? It's fairly easy to demonstrate why that's not true. So let's just consider this very simple example, which is not a good L'Hopital's rule problem, but is a little easier to understand why infinity minus infinity is in fact indeterminate. So if I take the limit as x approaches infinity of x squared minus x, um, if infinity minus infinity just had a blanket rule of it's 0, then this would be a limit of 0. But we can easily see that that's not true just by rearranging that expression a little bit. If I factor it out and write x times x minus 1, what we can see is that as x approaches infinity, clearly this x is approaching infinity, and x minus 1 is actually just 1 behind it and still approaching infinity. So this is really just infinity times infinity, which is infinity. So you can't just subtract infinity from something that's infinite from something else that's infinite and always get 0. It really depends on the nature of it. It depends on what the functions are. So let's try one that works a little bit differently. So we're going to evaluate this limit, which is limit as x approaches 0 of 1 over sine x minus 1 over x. And what we can see is that substitution of 0 is going to give us 1 over 0, which is like infinity, minus 1 over 0, which is also like infinity. So this is in fact an infinity minus infinity type of limit. So what we want to do is we're going to say that this is equal to, we need to do a little bit of algebraic simplification. We want to try to turn this into a 0 over 0 or infinity over infinity type of limit. So I'm going to find a common denominator. I'm going to multiply 1 over sine x by x over x. So that'll give me x over x sine x, and then I'm going to multiply 1 over x by sine x over sine x. So that gives me sine x over x sine x. So simplifying further, this gives us x minus sine x over x sine x. We can see now that when we substitute in 0, we're going to get 0 minus 0 on top and 0 times 0 on the bottom. So this is in fact now a 0 over 0 limit. We can go ahead with L'Hopital's rule. So this is now, by L'Hopital's rule, this is going to be the limit as x approaches 0 of the derivative of the top is going to be 1, I don't really need that parentheses, 1 minus cosine x over the bottom. We're going to need the quotient rule, so that's going to be x times the derivative of sine x, so that's x cosine x, and then plus 1 times the derivative of x is 1 times sine x, so it's equal to that, to this limit. Now let's try substitution again. Cosine of 0 is 1, so in the top we have 1 minus 1, and on the bottom we have 0 times 1, which is 0, plus the sine of 0, which is 0. So we have, once again, we have 0 over 0, and we can use L'Hopital's rule another time. That's going to give us the limit as x approaches 0 of the derivative of the top is going to be 0 minus negative sine. So that's going to be sine x over, and on the bottom, we need the product rule for the first term, and then sine x, just its derivative is just cosine x. So this is going to be x times negative sine x plus 1 times cosine x, which is cosine x, and then the derivative of sine x is cosine x. So this is equal to the limit as x approaches 0 of sine x over 2 cosine x minus x sine x. Substitution, and notice I did not write the L'Hopital's rule because I didn't take a derivative again, I just did more simplification. Using substitution, I get sine of 0 is 0. On the bottom I have cosine of 0 is 1, so that's 2 times 1 minus 0 times 0. So by substitution I have 0, 2 times 1 minus 0. That gives us 0 over 2, which is 0. So here's an example where infinity over infinity does equal 0. Just in the introductory example, it wasn't.